In today's episode, I will show you how you can add the ability to sort the inventory based on the item's category, name, or the amount on a slot. But before we get started, there are two bugs that I want to fix. So the first one is that when we right click on an item, see our action menu, and if we close the inventory and reopen it, our action menu still appears. The other bug is that when we right click on a map, read that, and close it again, now when we right click, you can see that our mouse cursor will be hidden and that we can't move it anymore. So let's fix that. To fix the map, we will go inside of our blueprints folder and on our item map. Here on the onRed event, when we set the input mode to game and UI only, you want to uncheck hide cursor during capture. Compile and save. For the action menu, let's go to our inventory system, to blueprints, and on the BP inventory. Now let's go to the function called hide inventory. And right before we set the slots panel enabled again, we will copy over the inventory widget, get the action menu, and set its visibility to hidden. Now compile and save, and that should fix the two bugs. Now let's actually start with implementing the sort functionality. First off, we will go inside of the enums folder and right click to create a new enum. That will be called e_sort type. In here we will define by what values our inventory will be sorted. First off, we can sort items by their category, then also by the amount, and by their name. Save and close the enum. Another thing that we will need later on is to go inside of our structures folder, and on the sitem info we will create a new variable. That will be the internal name of the item, so that won't be displayed, but it will be used when we compare the names of two items, so make that a string. And let's go to our item classes, BP master item, compile and save that. And now we will go to all of our child classes, expand the item info. For the internal name, just type in the name without white spaces and without capitalization. So hero sort. Then compile and save. We will also have to do that for all of our other items, but I will skip that process. Alright, now that we've set up all of the items' internal names, we can go to the blueprints folder and open the BP inventory. Let's add a new function here that is called sort inventory. It will have two inputs. The first one will be the type, and the variable type will be the e_sort type that we just created. Then also create a boolean that is called reversed. So do we want to sort them in exactly the opposite order? Before we work with that function, let's actually give the player the opportunity to call that function. So close the BP inventory, go to your widgets, and on our inventory, we will add a button to sort the inventory. But before that, we will search for a size box, drag that on top of our horizontal box, and then hit that little left arrow icon here to move it in between the text and the button. Now we will check the align right and vertically align center. Give it a width and height override. Width can be 70 pixel and height 30. Then you want to search for a combo box string and add that on top of our size box. So with that combo box, our user will be able to define by what value he wants to search the inventory. Let's actually clear the content padding for that. And under style, for the down arrow image, give that X value of 4 and Y value of 4 pixel, because we don't need it that big. Let's also give it a name, so that will be the sort type box. Now we'll add a button, search for a button, drag that on top of a horizontal box, select that button, hit the left arrow key here. Also align that to the right and to the center. That will be our sort button. Now for the padding, give it some padding to the left, 5 pixels should work. And under style, for normal, you can select the sort button default texture that comes with the texture pack from the last video. Also draw that as an image. For the hovered, select the sort button hovered, draw as image and give it a tint. Something like a bright blue should work. Then you can copy the hovered style, paste that for the pressed, and just go to the tint and make it a bit darker. Alright, that's it for the layout. We also want to populate that sort type box with our enum. So to do that, go to the graph, to the event graph, and right click here to search for event construct. When we construct our inventory widget, we want to right click and search for each e underscore sort type. For every entry of our sort type enum, we will add an option to our sort type box. So grab that here, search for add option, and the option will come from our enum value, which we will convert to a string. Choose the enum to string and not the byte to string. After that, we also want to copy over the sort type box and set selected option. For the in option, drag off of the sort type box and get option add index. Index will be 0, so our first option will be the option that is selected first. Let's select our sort button and add an onClicked event. So when our button is clicked, we will go into a flip-flop, which means when we click it once, it will go into A. When we click it another time, it will go into B, then into A again, and so on. For the A, we will get the inventory and search for sort inventory. The type we'll have to get from our sort type box, so get that. And now we want to get selected option. Drag off of the sort type box once again and search for find option index. And then plug in the return value of get selected option for the option. So now we've got our current index. Then we will convert that to a byte. And the byte we will convert to e underscore sort type. So we recreate the enum value that is selected here, plug that in for the type, and leave reversed as unchecked. Then we can copy that over, connect the inventory, and connect the category. And for the B, we will check reversed. Or you could just use the is A and search for not, connect that to the reverse, just as you like. Alright, that's it for designing the inventory widget. Another thing we could do is go back to the designer, and you see that there is a lot of space between the two buttons here. So just change the left padding from our close button to 5 pixels instead. Now let's work on our sort function. For that we will go to our BP inventory. And first off, we need another helper function to do that, and that will be used to filter out all empty slots because we don't want to sort them. So call that filter empty slots. And then give it an output, which will be the out array. For the type, select s underscore inventory struct, or s inventory slot, make it an array. Let's also create a local variable, which will be the local array. Change the type to s underscore inventory slot and make it a variable. Also, I noticed that it creates a default value here. You will have to remove all elements, then compile and save. And when we filter our empty slots, we get our slots from the inventory. Search for each loop. And for each element, we want to break that. And with our item class, search for isValid. Then search for a branch. Now, if it is a valid class, we want to get our local array and add to it. What we add will come from our array element. Connect that to the true. When it's false, we don't want to do anything. Now, when our loop has completed and we've run through all of our inventory slots, we can go into the return node and return our local array. Compile and save that. Now we actually need something that is called a sorting technique. There are many different ones, but I will just show you how to implement the function called bubble sort. Though I know that it's the slowest one, but I think it's very easy to understand and it will get you started. So create another function called bubble sort array. Create an input that will be an S inventory slot array called inArray. And it will have an output that will be the sorted array. For the inputs we also need the sorting type, so type, and that will be e underscore sort type, and we also need the reversed boolean, question mark, and change that to a boolean. Do not make that an array, and also the type should not be an array. Let's get our inArray and promote that to a local variable called local array. Then get the reverse and promote that to a local variable as well. Now we will run a for loop. From the first index will be 0, and the last index will be our local array's last index minus 1. So we will go from the first element to the element directly before the last one. And the thing that is special about bubble sort is that you will always compare two elements and check whether they have to switch their position. So what we'll do is get the index, promote that to a local variable called local index 1, then get the index and add 1 to it, promote that to local index 2. After we promoted our variables here, we will have to get our type from the input and switch on it, then connect that. Now we can change the comparison based on the sort type. So let's do the category first. For that we will get the local array, get from it, add our local index 1, break the struct, off of the item class, get class defaults, and then break the sItemInfo, and copy everything, paste it, and just change the local index 1 to local index 2. Also we have to expand the sItemInfo so we have access to our category. Now off of the category we will search for toInt byte. Do the same thing for the category of our second index. Now we will compare them. Let's get the integer value of our first category. Off of that we will search for greater than integer, and we will compare it with the category of our second index. Now off of here we could search for a branch, but we also have to consider our local reversed boolean. So get that, and off of it search for select. Now if our local reversed boolean is false, we will get our greater than return value here, but if it is reversed we have to search for not and connect that to the true, so exactly the opposite. Off of the return value of the select node we search for a branch, connect that to the category, and if it's true we know that our two indices have to switch their position. So to do that we will get the local array, get from it, add local index 2, and promote that to a local variable, local slot 2. What happens here is very similar to our swap indices function that we already created some videos ago. After we did that, get our local array and set array element. Index will be local index 2, and for the item copy over the local array and get from it at the first index, connect that to the set local slot. After that we want to set another array element, this time at our local index 1, and the item will be our local slot 2. Now we can move that over, select everything and hit C to paste the comment, and that will be our swap indices part, and everything before that is just the condition whether we have to swap them or not. Now let's add another variable, and that will be our local count, Make that an integer, not an array. And every time we finish our for loop here, we will increase the local count. Search for increment int, just adds 1 to it. And after that, we want to check whether our local amount is equal to the last index of a local array. Because we have to execute our for loop as many times as there are indices in our local array. Off of the equal, search for if. If it's false, we will go into the for loop once again. If not, we can return with our local array as the sorted array. Now that is for the category. Later we will also have to add the comparison for amount and name, but we should be able to test that after we modified our sort inventory function. So go back to sort inventory. And the first thing we'll do here is to filter out all empty slots. Then of the out array we search for the length and check whether it's greater than 1. Otherwise we cannot sort that with bubble sort because we don't have a second index to compare the first one with. Search for a branch. Let's do the false first. If it's false, we will set our slots to the out array, so all of our slots that are not empty. But after that we have to resize it, and we will resize it by the amount of slots we have, which basically means that we will just add the amount of empty slots we had before at the end of our inventory here again. After that, we also want to see our slots updating, so for each slot we will call our update slot at index and connect the array index to that, and after it's completed we can return. However, if we have more than one item in our filtered array, we can get the out array and bubble sort the array. The type will come from our input and the reverse boolean as well. And after that we can copy over everything, but this time set the slots array to the sorted array before we resize it. Alright, let's compile, save, and let's test it. First we can see our combo box here with category, amount, and name. That is generated at runtime, so you could just go into the enum again and add some other options. Now let's move them and select category since we didn't implement amount and name. Now let's hit our sort button. And we see that they're now sorted by their category, starting with consumables, quest items, readables, and weapons afterwards. If we hit our sort button once again, you will see that they're now in the opposite order. So currently everything works fine. However, our player might not want to sort by the category every time. So let's implement amount and name. For that, just double click the bubble sort array function. Now for the amount, we will get at our two indices and break it. So let's copy over that part, paste it somewhere around here. And now we want to check whether the amount at index 1 is greater than the amount at index 2, or the amount is equal to the amount at index 2, and now for the second condition of the end, we will get the item class, get class defaults. Now split the struct bin here and connect our item info can be stacked to the end. Then connect the end to the OR, so which basically means we will swap the indices if either our amount is greater than the next one or it's equal and the first index can be stacked. Then let's copy over the select node with our local reverse boolean here. If our local reverse is false, we will get our OR condition here. If not, we have to add a not to it and connect the not to the true. Off of the select, search for if, move the branch down here and connect it to the amount. Then for the true, we will go to the swap indices function. Compile and save. Actually, let's delete the get class defaults and re-edit. Then of the item info, break that, expand it, and connect the can be stacked to the end. Somehow that didn't work the way I set it up. compile and save. Get some health potions. We can also split the stack, split it once more, split once more, split that one. Now when we select the amount, sort it, you can see that we have all of our non-stackable items, then the stackable item, one of it, 12, 13 and 49. If we hit it once more, you can see it's the opposite order. Now amount and category are working, and they're the easy ones. For the name we will have to add another function, because unfortunately Unreal Engine doesn't come with a function to compare strings based on the alphabet, so we will have to add that, which isn't that easy actually. So let's create another function called compare strings. It will have two inputs. First one will be string 1 and of the type string. The second one will be obviously string 2 and a string as well. And for the output we will need a boolean for the case that string 1 is located before string 2 in the alphabet. So call that 1 before 2 and question mark and make it a boolean, and add another one that will check if they are equal, question mark. First off, we will hit the plus sign for the local variable and add a local 1 before 2 question mark. Now let's drag off the string 1 and search for double equal case insensitive, and we will compare it to string 2, search for branch. So if they are equal, you can add a return node and return with equal. If they are not equal, we will drag off string 1 and search for get character array from string. So that will be an array with all of these single characters of the string. Then we will promote that to a local variable and call that characters 1. Do the same thing for string 2. Get character array from string. Promote to local variable characters 2. Connect that to the false path. Now after we promoted them, drag in character 1 array, drag in character 2 array, then search for the length of both of the arrays. And now we have to check which of our strings is the shorter one. Off of the length, search for less than or equal to the characters 2 length. And let's create a boolean that is called 1 is shorter, question mark. And then set that to the result of our comparison here. Maybe the name isn't really accurate because we also set it to true if they're equal. Feel free to change the name if you want to. Now we have to select the shorter array, so drag in the is shorter and search for select. If 1 is shorter, we will get our characters 1 array. If not, we will get the characters 2 array. And off of the return value, we will search for an for each loop with break. Connect the set is shorter to the execution. Now let's get the array element and search for get character as number. Index will be 0. Now let's copy over our select node. And that time when 1 is shorter, we will get the second array, so connect it to the true and the false to the character 1. So we will just get the array that is longer, get from it, add the array index, then off of the string search for get character as number, index 0, and now we can compare the two values. So off of the first return value search for compare int. Connect the loop body to the execution. We will compare it with our first character from the other array that we're not running through. If the value of the array we are running through is greater than the one that we are comparing it with, to the opposite of 1 is shorter. So 1 is shorter, not. Connect that. Let's create another local variable called broke out, question mark. Then set it to true. And after we set that, go into the break of the for each loop. Add some reroute nodes to make it look a bit better. If it is less than, we will set the local 1 before 2 to our one is shorter. And we can go to the set broke out true and break out of the for each loop. Now, when we completed our loop, drag in the broke out, search for if. So our broke out value will be false if all of the characters had the same numerical value. So we didn't set our broke out boolean here. So if it's false, the shortest string will be the one that is before the other one in the alphabet. So get in one is shorter, connect that to one before two, and leave equal as unchecked. Copy the return node for the true. And if we did broke out, we will connect the local one before two. Alright, that's it for our comparison of strings. I know that function is a bit complicated, so please have a closer look at it yourself. Now let's include that compare strings function in our bubble sort array. On our switch, we will compare strings. String 1 we can get from our break as item info here, and that will be the internal name at local index 1. The other one will be the internal name at local index 2. After we compared them, we want to check if they are equal. If they are equal, we don't want to do anything. If not, search for another branch. And let's copy over our local reversed and the select node. If our local reverse is false, we get the one before two. If not, we will search for not and select the opposite of it, then connect the return value to the condition, and if it's true, we will swap the indices. Compile and save, and now it should also work with our items. Okay, let's move them somewhere. Select the name and sort them. Now you can see that they are in reversed alphabetical order, but if we hit our sort button once again, they are in alphabetical order. Health potion before hero sort, after that map, and then ring. Alright, that's it for adding the ability for the player to sort the inventory. If you have any suggestions what you want to see in the next video, please leave behind a comment and I will see what I can do. See you in the next one.